Hello, welcome to this lesson in the linear algebra tutor. We're going to talk about what we call cofactors of a matrix here. Now, I mentioned to you in the last couple sections, I taught you how to take the determinant of a 3x3 matrix using my favorite method. I use it all the time. But I also told you that that was a subset of a broader technique. And so here we're going to start talking about the broader technique. Ultimately, you need to understand the broader technique for the purpose of matrix theory. In reality, I actually just use what I've already taught you before, but you will be tested on this stuff and how to find determinants using these different ways. So I need to make sure you understand it. So let's talk about the concept of a cofactor, and then you'll see how it ties in into what we're talking about here. We're going to talk about the concept of a submatrix first. And you already really did this. I just didn't really call it that, or at least too much. You know how I was telling you to cross out this column and cross out this row, and whatever you have left, that goes into your calculation? That was really what we called a submatrix. I'm just going to illustrate it here a little more explicitly or formally, like you might see it in your book. So if you had a matrix -1, 1, 2, 0, 6, 3, 4, 7, 5, something like that. Let's say you had this guy going on. Then you could form various submatrices. For instance, you could say submatrix A sub 1, 1. This means the location or the submatrix formed by going to row 1, column 1, and then crossing this guy out, just like we've been doing. So we have 6, 3, 7, 5. 6, 3, 7, 5. I'm not doing any determinants yet or anything. I'm just defining the concept of a submatrix. And then we've already done this a lot, so I'll kind of fly through this. A 2, 1 would be, or I should say 1, 2. A 1, 2, which means row 1, column 2. Row 1, column 2 would be covering this up. So I would have 0, 3, 4, 5. 0, 3, 4, 5 because I'm covering this guy up. And a 1, 3 is the submatrix formed by taking this element and covering this and covering this. So I have 0, 6, 4, 7. 0, 6, 4, 7. Now, to be absolutely explicit, see, what we've done here is I've defined the same submatrices that I've been using with you by going through this first row. But you can define a submatrix by going through the second row, too. This is how it starts to get a little broader than what I've taught you. So a 2, 1, which means row 2, column 1, is this element, row 2, column 1. So if I look at the intersection, I would cross this out, and I would cross this out. So I would cross this out and this out, 1, 2, 7, 5. See, that is a valid submatrix here. 2, 2 would be this middle element here, and I would cross this guy out and this guy out, so I have -1, 2, 4, and 5. Basically these guys around here because I'd be crossing that out. And 2, 3 is row 2, column 3. I would be going for this guy, so I'd cross this guy out and this guy out. So think of it as this and also this. So I have -1, 1, 4, 7. -1, 1, 4, 7. All right. So that goes through the middle row, finding these submatrices here. And I can also define 3, 1, going through the bottom. So if I cross this guy out, I'm crossing this out with this, 1, 2, 6, 3. And then a 3, 2 is this guy here. So I cross this out along with this. So I have -1, 2, 0, 3. -1, 2, 0, 3. And a 3, 3 is just the guy here. So I would cross this with this, and I would have -1, 1, 0, 6. -1, 1, 0, 6. Let me take a step back and make sure I didn't lead you astray, make sure I have everything right here. Those are correct there. Middle row, -1, 1, 4, 7. Then we have 6, 3, 7, 5, 0, 3, 4, 5, 0, 6, 4, 7. Okay, so these are what we call the submatrices. You've already used submatrices because I've already showed you how to really do this technique, but I was careful to tell you, hey, in the previous technique we were expanding the determinant about the first row. That's why we ended up using these 3 matrices, because this technique is going to use the submatrices. That's what we basically are talking about here. But you can also define submatrices for any row, right? So these are the submatrices when you go through the middle row, and these are the submatrices that you form when you go through the bottom row. I'll give you a little bit of a preview. You can find the determinant by expanding about any of the rows in the matrix. We have been doing it in the previous sections by just looking at the top row because it's easiest. But really, you can expand it through any row that you want. And we're going to get to that here in just a little bit. So we have defined the concept of a submatrix. I need to finally talk about what the name of this section is, which is called the cofactor. So I will tell you that there is a cofactor at every location in the matrix. Right? At every location in the matrix. So that means that there's a cofactor that's defined at this location, at this location, and this location, different cofactors, which I'm going to show you how to calculate in just a second. The cofactor at location ij, that means the location at row column, so row 1 column 1 or row 2 column 3 or whatever location in the matrix ij is going to be equal to something that scares students at first, but it's not too bad, -1 to the I plus j times the determinant of the submatrix ij. So this looks complicated, but I promise you it's not complicated. Basically, what's happening here, this term is the determinant of the submatrix that's formed in all of these locations. I wrote them all on the board to give you a concrete thing, but let's say we're going to look at this position. Well, we know that there's a submatrix that comes about when we cross this and cross this out. This is the submatrix to A sub 2, 3. This is the submatrix at A sub 3, 1. So what's happening here is to find the cofactor at that location, you take the determinant of the submatrix that's formed at that location. This is just a number. Remember, determinants just give you a number. So this is just going to yield you a number. Then it's either going to be minus or plus on the front. Notice how when you take -1, you raise it to a power from algebra. If you have a even number like -1 squared, -1 to the 4th, -1 to the 6th, -1 to the 10th, anything with an even number, then the -1 goes away and you just end up with positive. So this would just disappear. But if you have an odd location where I and j, when you add them together, they yield an odd number like 3 or 5 or 9, then because of the way you do the exponent here, you get a -1 out in front. So the bottom line is the cofactor at any location in the matrix at row I and column j is either going to be negative or positive, which just is going to depend upon the row and the column location, times the determinant of the submatrix that's formed at that location. And I'm giving you a concrete example so you can lock that in your head. So the cofactor, bottom line, is just a number. Cofactor is a number. It's not a complicated matrix or anything. The cofactor is just a number. Okay? You're going to get the determinant of the submatrix at that location, and it's either going to be negative or it's going to be positive, depending on the exact location. So this equation gives you the details of that whole, if it's negative or positive business. But I will also tell you that there's a pattern that is formed, okay, when you look at this. So for the pattern, it's a little bit easier to visualize what's happened here if I just go ahead and show you the pattern. In a matrix, in row 1, column 1, it goes like this: plus, minus, plus, dot, 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 and then minus, plus, minus, dot, 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 plus, minus, plus, dot, 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 and then you have dot, dot, dot this way, because it depends on how big your matrix really is. But this -1 to the I plus j, I'm just visualizing that for you. In the top left location, this is 1, 1. This would be -1 squared. 1, 1 gives you 2, so that gives you a positive number. But as soon as you move over to the right, row 1, column 2, I plus j will give you an odd number, in this case 3. So that's why it gives you negative. This sign would end up giving you negative. But when you go to the next location over, this is row 1, column 3, I plus j is 4, and so then you would have a positive sign from this little calculation. When you go to the next row here, row 2, column 1, you add that, you get a 3, you get a negative number. And so it alternates throughout the matrix like that. So to find the cofactor, just to boil it all down, what you end up doing is you find the determinant of the submatrix, like we've been doing all along, and you either put a minus or a plus out in front of it, depending on the location where you're at. Okay, and this is the pattern, and this is kind of how it's done. Now I'll give you another kind of little heads up. Remember when I taught you how to calculate the determinant of the 3x3 matrix, I told you, hey, for that second term you have to remember to put a negative there. I told you about 10 times, don't forget that. Right? That's because we were always expanding about the first row of all of those matrices, and look at the pattern here. The cofactor pattern, which I haven't really given you the full glory of it, but I'm showing you that the negative sign comes from this cofactor, which is always negative here. In later problems, if we end up expanding about the middle row, then you'll have signs in different terms. The first and the third term would be negative, and the middle would be positive if we were to expand about that second row, and I'll show you how we do that later. But the bottom line is the negative, the magic negative I told you, don't forget, it comes from the cofactor calculation. All right, so let's just kind of dispense with this, and let's say that we want to actually do some calculations. So using this matrix over here, well, let's go, let's just go ahead and do it underneath here, I guess. We'll kind of go spill over into the other board. If we have, let's go ahead and find the cofactor at location 1, 1. Right, so what is that going to be? Well, at location 1, 1, we go to our cofactor here, and it's going to be -1 to the power of I plus j, but we know that in this first location, because we can look at the pattern also, it's just going to be positive, because 1 plus 1 is 2, and that gives you a positive number, so we can say this positive times the determinant of that submatrix. So really what it is positive, so we just say it's the determinant of A11. We already know what A11 is, it's right here, so we say it's the determinant of 6375. And we already know how to find that, so it's going to be 30 minus, this gives me 21. And that's positive 9. So the cofactor at location 1, 1 is just equal to positive 9. All right? Now let's look at the next one. Let's say we want to find the cofactor at location 1, 2. Well, we go to our cofactor formula, and it's going to be either negative or positive. We don't really have to calculate it because we look at the pattern, and we see that at location 1, 2, row 1, column 2, it's negative, which comes about because row 1, column 2, you add these, you get an odd number, which makes it negative. So it's going to be negative times the determinant of the submatrix A12. So we just say negative times the determinant of the submatrix A12. We already know what that is, 0, 3, 4, 5. 0, 3, 4, 5. So we keep the negative like we always do, and then inside it's going to be 0 minus, this guy is going to give us 12. So really it's negative 12 times this, so we again end up with a positive number, positive 12. All right, so when you find the cofactor, you've got to figure out first if it's negative or positive, and then it's just times the determinant of that submatrix. All right, so let's say we're going to do C13. So again, we're going through that first row. We go and figure out in the first row, row 1, column 3, we see it's positive, right? So it's going to be a positive number, determinant A13, okay, which is the determinant of that submatrix 1, 3. We go up here, 0, 6, 4, 7, 0, 6, 4, 7. And going this direction is 0. This direction, 6 times 4 is 24. So the answer we get is negative 24. So this time we get a negative number for that determinant. So the cofactor, now we've found C11, C12, C13. We basically have found the cofactor at this location, the cofactor at this location, the cofactor at this location. And as I've said many times, you can find a cofactor at any location in the matrix where you have a number, basically. So let's find one more. Just to kind of round it out. Let's find C, let's do something different. C23, what would that be? Row 2, column 3. Well, first you can see that if you were to add 2 plus 3 together, you're going to get an odd number, you're going to get 5. And because of the way the exponent works on the -1, it should be a negative that you get. But you can also look at the pattern. Row 2, column 3, you can see that there's a negative there. So however you want to do it's cool. Either way, you got to put a negative here times the determinant of A23. All right? And so then what you want to do is negative times the determinant A23. You look in here, we've already found the submatrix here, A23, negative 1, 1, 4, 7. Negative 1, 1, 4, 7. So we put a negative here, and then inside we go like this, which will be negative 7, minus this way will be a positive 4. So what we see is we have a negative on the inside, negative 7, minus 4 is negative 11. So inside we have negative 11, we have a negative outside, so we can just make it a positive 11 for the final answer. So the cofactor at location 2, 3 is 11. Now the reason I busted out the concept of cofactor separately is because once you know how to find the cofactors of a matrix at any location, you know how to find the determinant 9 ways to Sunday. I mean, there's a million different ways in which you can find the determinant. We have, in the previous sections, always been expanding about that first row. So hopefully you can kind of see where we're going. I was telling you before, if you were to find this determinant of this matrix with the previous methods, you would say this times the determinant of this submatrix. This times the determinant of the submatrix, you got to remember the -1. This times the determinant of this submatrix. And now you know where the -1 comes from. It comes from the cofactor in that location is negative because of this pattern over here. So you already kind of have figured out what we basically were doing in the previous sections is we were just expanding the determinant using that first row. So I've kind of introduced the concept of cofactors. Let's tie it all together in a nice bow. Let's go to the next section. I'll show you how the actual formalization of how you find the determinant of a matrix where you can expand it through any row or any column you want. So let's go and take a look at that now.